This video is going to be about the formation and types of precipitation. This should be target 2C in our weather unit. As you can see in this picture here, there are many different types of precipitation. This is often something that people get mixed up, particularly the difference between rain, freezing rain, sleet, snow, and we'll talk about hail towards the end. It all has to do with temperature and phase change of water in our atmosphere. So first we'll talk about snow. Snowflakes and snow crystals, this would also be true for frost just forming on a surface. They're actually made of ice, but they're ice crystal. They grow directly from water vapor. That process is called deposition, which we already know. So it's a crystal of ice. Snowflake is just a general term that we use, and it could be a few crystals stuck together, or it could be a large cluster of crystals. So there's a lot of math involved with crystal growth, as we talked about in our minerals unit. But what they actually grow into is called a hexagonal lattice. And in this picture here, you can see the red spheres are hydrogen atoms, and the gray sticks would be the oxygen atoms. So these actually grow into a geometric structure. Ice that's just frozen or formed first from liquid into a solid does not grow into the shape of a lattice or any type of crystal. So here you can see the factors that affect different snowflake growth. It depends on temperature and humidity, which we've already talked a lot about this year. So you can think about simpler shapes being low humidity. Complex shapes grow at higher humidity. So if you look at this X and Y axis, we have that supersaturation, which is really just the humidity amount, and then we have these different temperatures. You don't really have to know any of these specifics, but at least you'll know why we have so many different types of snowflakes. And some of you have probably heard the saying that no two snowflakes are alike. There's no real science that proves that that's true. However, if you think about any type of snowflake that's falling through the atmosphere, no two snowflakes take exactly the same path. And as you go through the atmosphere, the temperature and the humidity changes. There's lots of different ways to talk about snowflakes. If you're really interested in it, there's this great book made by Dr. Liebrick, and I'll have a copy of it in my classroom if you're interested. Hundreds of different types of snowflakes. This is his categorization of it, so you can see all of these different types. A lot of these you would need to see with a microscope, or at least a basic hand lens, in order to see the snowflakes up close. So let's talk about how snow, rain, freezing rain, and sleet are different. Here's a great picture that shows how a warm front can interact with the atmosphere, and a lot of times we'll have different precipitation out in front of a warm front. It has to do with how does that atmosphere actually change as you go from the bottom of the clouds towards the surface. So first let's talk about sleet. Sleet is frozen raindrops. So snow, most precipitation starts out as snow and then it falls through the atmosphere, and in sleet's case it's partially melted. So you can see here there's these partially melted snowflakes here. They kind of lose their crystal growth and then they refreeze before they hit the ground. So those tiny little pellets in the winter or spring sometimes, lots of times people will call it hail, but it's not hail. It can hurt if it's blowing, but these are really small and you'll hear them like pinging and tinging against the windshield or glass on a window. Hail is formed very differently. Freezing rain is just that. It's rain. However, it has fallen as snow and then it hits a warm layer, but it completely melts. It does not refreeze before it hits the ground, and it will be hitting a surface that is below 32 degrees, and the actual raindrop itself is super cooled. So it is right just above the freezing point usually, and that'll form a glaze on different objects. You've probably seen this before. It can be quite damaging to power lines and tree limbs, and it's very difficult to drive on. But you'll notice that it does not have a crystal growth. Neither does sleet. They look very different. And I don't think we probably have to talk too much about rain, but even if precipitation starts out of snow, rain will be when it's warm from when it changes from snow, or it starts off maybe even as rain too, like in the summer, and it falls all the way through the atmosphere to the ground where it is still above freezing and it is in liquid form. Snow would be the complete opposite, where it is cold through all layers of the atmosphere from the base of the clouds to the ground, and it builds up and accumulates on the surface of the earth. However, if the surface of the earth is warm, it will oftentimes melt and not accumulate. What is hail? Well, hail is the form of precipitation that occurs when updrafts and thunderstorms carry raindrops upward into extremely cold areas of the atmosphere where they freeze into ice. Hail can be very damaging. It can actually kill people. You need that significant convection in updrafts and downdrafts to get the growth of ice to be this large. Most hail is not this large. Most hail is pea size or less. They can get really big. Okay, so the larger that cumulonimbus cloud, the taller it is, and the more wind you have going up and down in that cloud, it allows for the hailstone to grow, kind of like rings on a tree. So here you can see some really cool pictures. This one here shows the growth rings. So this would be a single hailstone that grew and grew and grew based on how many trips it took in that cumulonimbus cloud. Here, these are also pretty common, where there are much smaller stones, but that would be considered a conglomerate of many hailstones. So those stones collide, they melt, and then they freeze together, they melt, and they refreeze, and they pick up more. Here's just another diagram where you can see how that hail can be pulled up into the thunderhead, and eventually it gets too heavy for the cloud to hold on to it, and it falls. So those are our different types of precipitation. Make sure you know how each one forms, and that really helps to explain, all those different colors that we have on the radar. All right, so be able to compare and contrast. That's target 2C of the clouds section of our weather unit.